Two functions f and f of x equals what? The output.
Fx equals 3x plus 1.
Replace.
Plus 1. And gx equals x squared.
Is that ready?
Yes.
Oh. Okay. No worry, that tells us then. We have two equations ahead of us, in front of us. Both are saying the function of x, not because it's a g. Remember I said, if f is being used already, g is the next letter in line that they use. Then after g, if using 3, the next letter in line will be H. But you can actually randomly use any letter you prefer. But these are the conventions that they normally have. This is saying, after this rule is applied, what is the output? So the input is here. This is the input. Alright? And the whole thing out here is the output. Okay? They're saying, put x inside here, right? If you put x inside here, what's the equation now, sorry? F1. X minus 2?
Yes.
Right. Whatever is in here has to go in here. This is what you do. You write back this x as a bracket. Okay? Plus 1. Reason being is treat it like this. 3 times what input? The input is x, so you put x. Let me use red. I'll use red. The input is x, so it becomes x. The input is x minus 2. So the input is x minus 2. Another way you could do it, this is just me randomly doing something. If I say f is 3, and Mr. 3 is coming to the party, then you do what? What goes here? 3. That means 3 times 3 is what? 9 plus 1 is? So Mr. 3 girlfriend is 10. Imagine that? So what goes in here goes where the x is. Wherever the x is, it's replaced. If it's x minus 2, then x minus 2. If it is 3, then you put 3. You understand?
Yeah.
Remember, this is what I made up. I made up that, okay? Good. So as I remove that, we have this now. Think about a box. Pretend that you have a box and you're looking within the box. If you open the top of the box, what do you see inside? I see inside what? X minus 2. The same thing with this. You look inside the box and see x minus 2. Okay? Now this can what? This can expand. You might understand? Which will give you what? 6 plus 1. Which gives you 3x minus 5. Okay? So whatever is in here goes in a bracket. Okay? So whatever goes in here, it's x minus 2 go in the bracket. So what you do is simply write back the equation, but write it back, give it some space, treat it as a box. And then you put it in. They tell you what is inside, well, this is inside. Okay? You're gonna look unfamiliar to some people who ain't doing it in years. Those who just leave school, it should be familiar to you. Okay? Now, what's the other one now? There's another one here. G.
Equation?
Yeah.
Or G.
Or 3.
Okay, 3x plus 2.
3x plus
2.
2.
Bracket plus 10.
Sorry. 3x plus 2.
Close bracket plus 10.
Plus 10. So what is happening here? This 10 has nothing to do with what's going on here. Okay, it has something to do with it. I'm not say it that way. But pretend the 10 is not there. Okay? Leave the 10 off Salah. Okay, we got it up here. That's what we remember. 3x plus 2 plus 10. Leave the 10 off. Okay? G of this, if I can write it back, will be what now? Remember I told you, wherever you see x, you put what? Wherever you see x, you put what? Remember this was 3x plus 1. Wherever you see x, you put a what? Say for me please. Wherever you see x, you put a? Good. So whenever you see x, you put a bracket. So this is what? X squared, right? So this is what? X squared. It's just that we substituted. Remember algebra is all about substitution. So what goes here now? 3x plus 2. Squared. Close bracket squared. Very good. So then, what is happening here? 3x plus 2 times. Good. 3 times 3. X times x. 3 times 2. Let's give me the whole thing. 3x times 2. 6x. 2 times 3x. And 2 times 2.
4.
So 9x squared plus 12x.
Plus 4 plus 10.
Good. So now, this is what happening now. We're going to bring back with 10 now. Remember I left it off? Let's put it back now. Plus 10, plus 10, plus 10. Can we go further? Can we go further?
Yes.
What it is?
10.
9x squared plus 14. So this was a tricky one. Even me at the pass. But normally when they give you, normally when they give you it looking like this. Okay? Is an equal sign or arrow? What else? Equal sign? Something they put arrows. Sometimes I see this, something I see that f of x goes to 3x plus 1. Sometimes I see arrows, okay? So everybody understand what's going on here? Again, we're going to backtrack. Treat this x as a bracket. Wherever you see x, you make it a bracket. So we saw x here, we wrote it back as a bracket. Okay? The plus 10 was added on because that was the original question. That's what is g of 3x plus 2. So we have to find that separately. And then we're going to find that add 10. Okay? You understand? Good. This one was a little much more simpler than this one. But that's the question I asked for. That's it?
Yeah, that's it.
Well, that's it? So calculate the value of what?
F4.
F4. I'm going to write it back. F. What's happening here, class? It said find one, calculate one, F1, 4. So wherever you see X, you put what? 4. So pretend X is a box, you look it in the X, and what do you see? 4. Okay? So 2 minus what? 20. So F4 is what? Negative 18. What is this saying? That 4 goes to negative what? 18. That's the relationship. You get negative 18. Why? You have to multiply 4 by negative 5, and then you subtract the product of that from 2. Where you see x, you substitute 4. This is basically, we can put a word. This is basically what we're doing. Substitution. This is basically substitution we're doing. Alright? Where you see x, you put 4. So we have negative 5 times 4 is negative 20. 2 take away 20 is negative 18. So when you multiply 4 by negative 5 and take away the product from 2, you get negative 18. Can I put another number here? Can I put another number here?
Yeah.
I could do it for 3. Minus 5 times 3 is what? Minus 5 times 3 will be what? Minus 15. 2 take away 15. Negative 13. Good. So in this case, x and the friend of x is 4 and negative 18. Okay, imagine that? Those are the coordinates. What next question I have to know? H0. Let's put my other thing here. H0. So let's write back the formula first. H. You see what I'm doing? I help you out there. Wherever you see X, you create a box. Okay? So X is what? It's a 0 or 0?
Yeah.
You're not gonna take the bike on this way.
If you're trading garbage,
I got forced to buy it
exactly.
out of my money.
What I know, how many you want to those now?
What's the answer?
1.
What's the answer, class? Why is it 1? Why is it 1, class? They're going to be quiet. Yes. No, not like that. One thing like more you do try. You're in a column with people who not try. You're in a column with people who sticking up with crackers and water. Why is it, class? Class, why is it 1? Anything raised to the power is 1. Remember, you can't listen to that next thing. If I listen to something here, you come and pick it up.
Thank you.
Anything raised to the power of 0 is 1. I don't know if I ever showed you this. 10 to the 0, 10 to the 1, 10 to the 2. Then I gave you 10 to the what? Negative 1, 10 to the negative 2. 10 to the 0 is 1. 10 to 1 is itself. And 10 squared is 10 times 7 is 100. This is what? 1 over 10 to the first power. This is 1 over 10 squared, which is 1 over 100. Okay? You understand? So it could be this as well. It could be 7 to the power of 0, 7 to the power of 1, 7 squared. 7 to the negative 1, 7 to the negative 2. 7 to the power of 0 is what? Still 1. 7 to the power of 1 is what? 7. There's only here 2 people. 7. And 7 times 7 is what?
49.
It's going to be what? 1 over what? 7. It's going to be 1 over 7 squared, which is what? 49. Okay? So anything raised to the power of 0 is the powers that are negative gives you fractions. Fractions and decimals come from negative powers. Okay? And you guys still did you know that there are something called fractional powers? Fractional powers give you roots. But that's you don't need to know that for CXC. Yes. Alright, let's go. Let us see pass it. Next question asks finds FH negative 2. FH negative 2. Now, this is what we're going to do. This is what we call, when you look at the document, look for this, composite function. What does composite mean, or composite? What we want to pronounce it? I rather hear composite. Composite or composite? What does that mean? To bring together. And you could tell, they have an equation within an equation. So they have a number which is within an equation, and that number within the equation is in another equation. So you can put an equation into an equation. So this is what I do. There are more than one methods. But I rather this. Write that f of x first. Write that for me, please. The outer shell and the inner shell. I call them outer shell and inner shell. This is outer. This is outer, that's why. This is outer. And this is inner. There's an inner formula and there's an outer formula. Okay? So write the outer formula first, guys. Write the outer formula first. Write it back the regular way. F of x equals 2 minus 5x. Then you're going to rewrite it without any x. Okay? Just rewrite it, leaving it with the open shells or boxes, whichever way you want to call it. Okay? Then inside of there, you're going to put in the inner formula. You understand? This is the outer formula. This is what? The inner formula. What's the inner formula? H of x. Okay? So what is h of x? We have it up on the board. What is
0.
h of x? Is really what? 5 to the x power. 5 to the x power. Okay? But to tell you what x is. X is what? Good. So we have h of x within f of x, and within h of x we have negative 2. 5. I shall keep it red though. Yeah. Keep it red. 5 negative 2 equals 2 minus 5 to the negative 2. Should I use another color for that? Alright, we just established this as a while ago. We just did something like this. I did it with 7. Can it work with what? Can it work with 5? 5 to the 0, 5 to the 1, 5 to the 2, 5 to the 1, negative 1, and 5 to the good. 5 to the 0 is what? 5 to the 1 is itself, good. This is what? 5 times 5. We put 5 there, and some people say 10. 25. 5. You are multiplying by 5 each time. 5 times 1 is 5. 5 times 5 is 25. 5 times 25 is 125, which is 5 to the third power, okay? Which is 5 times 5 times 5. Over here now, it's 1 over 5 to the 1 power. 1 over 5 squared. You know, 5 squared is what? 25. So 1 over 5, 1 over 25. So we have this. 5 to the negative 2. 5 to the negative 2 is 2, 1 over 25. What's next? Shakira, what's next? You might show the top. Shakira, what's next? You're done with it. I'll take an answer from anybody. Any of you. What does bracket says? What the bracket say here? So based on the calculator, you calculate the answer. Okay, calculate the calculator. But what needs to be done? Everybody, you multiply negative 5 by what? 1 over 25. This is actually saying what? Yeah. You could put it like that. I know how to see it that way, okay? Treat the 5 as 5 over 1. What do you think will happen here now? So what we left with? Tell me. 2
minus 1/5.
1/5. 2 take away 1/5. But use your brain. You got 2. I take away 1/5. What did the answer going to be off the bat? If you take away a quarter from 2, what you left back with? From 2. 1 3/4, right? If you take away a third from 2, you're left with 1 2/3, right? So if you take away 1/5 from 2, 1 4/5. But I'm going to show you a little technique. Look at this. 2 take away 1/5. I'm going to teach you a little technique. I don't want to learn it from today. Whenever you have a whole number here, everybody watch please. Whenever you have a whole number here, always multiply it by this number down here. 5 times 2 is what? 10. So 10 over 5. You put it over 5. Now let's backtrack. 10 divided by 5 gives you what? 10 divided by 5 gives you what? 2. You see it? Yes. So this and this say the same thing. How did I get it? The trick is multiply that by 2. 5 times 2 is 10. And put all them having the same one. And why do we want that? Now you go subtract. Because that's the same denominator. 10 from 1 is what? How much times 5 we're going to 9? Remainder of 4 over 5. Positive. 3x plus 2. Remember I started out with that, right? X over here, f of x over here. Everybody pay attention over please. I chose 1. I put 1 into the machine. The machine said 3 times 1 is what? 3. 3 plus 2 give me what? 5. In maths, there's always a reverse. There's always a reverse. If I can go from A to B, I must be able to go from B back to A. So there's an inverse for this process. But think about it. The last thing I did was added 2, right? So say I had 5. If the last thing I added 2 was added 2, what the first thing I think you should do? Subtract 2. So 5 take away 2. Good, right? You put that together. Right? And then I multiply by 3. What's the opposite of multiply? So divide by 3. Right? So guess what now? Let's finish off this. 5 minus 2 is what? 3 divided by 3 is what? You see that? So if 3 times 1 plus 2 is 5, 5 take away 2, divided by 3 give me back the 1. That's what we call the inverse process. So every formula you have can be reversed. Okay? So now, what formula do I want you to find the inverse of? You have f of x, let's go class, immobile again. Time is going. This is the rule now. Sister, you have to write down these things. Okay, you have to write down these things. F of x equals 2 minus 5x. The first thing you do to find the inverse is to change f of x to y. You see how simple that is? The first step, I need space. The first step, hold on, I'll show you the different color. Anyway, may I tell you that. First step. What's the first step, class?
Change x to y.
I said change the x to y. Change f of x. I didn't just change x, I changed what? F of x to y. If it was g of x, it still will be changed to y. If it was h of x, the first step is to change it to what? Y. You understand? Now remember, x and f of x. F of x means y. Okay? That's the first step. The second step is to change y to x now, as I will try to point out, and x to y. So we call this second step, and we're going to say, we're going to interchange x for y and y for x. Yeah, you take a picture. Can you take a picture of this? Yeah.
I will wait until you don't let your weight so close.
Okay, I'll wait here. I'll wait to get it closer. Okay, imagine that. What's the first step?
Change x of y, I will help us to say to y.
Change f of x to y. Second step is what? Interchange y for x and x for y. So where you see y, you put x. Where you see x, you put y. That is basic things you could do. Right? Then the third step, everybody remember what the third step is? Big with T. Transpose. Transpose to make y the subject. Transpose means to rearrange for those who don't know. Okay? We're going to transpose to make y the subject. Somebody have to help me with that. Kelsey? What's your name again, sir? Huh?
Queen.
Queen. No, first name.
Fine.
Yeah, man. But that is
Just go.
I want to know his name. I can have the register for anyway. Kamani, yes. Don't give me the half, give me the full thing, because I don't know it as Kamani. Kamani, I remember Kamani now, yes. Yeah, guys, you can see. Let's go, guys. Transpose to make wide the subject. What the first thing you move? 95. Somebody in this relationship is on the outside. So X is already on the other side, so we don't trouble X. Remember we want to, when you transpose for either Y or X. We're not transposing for X, we're transposing for Y. So we need to move these fluff. There's a marriage here and there's a girlfriend in the marriage. So who's supposed to move? So give me the equation, please. In steps. X take away 2 minus 5y. Good. And then X take away 2 divided by negative 5. Second y. And then from here, you're finished. You swap them around, you put it as f inverse of x. Y in this case will be f inverse of x. And x minus 2, sorry, put that back in front. X minus 2 divided by minus 5. I'll show you a little adjustment. We could have made we could have made negative 5y positive first, which I always teach all you. Don't try to have the negative out here. But we could have done, I'm not going to go fast, but I'll tell you what it does to me. Carry over that and bring over this. Who could do that for me? We're going to carry this over and bring this over. So what the equation would be? 5y. Remember this coming over? Equals 2 minus x. So y equals what now? No, let's look at this and let's look at that. They're not the same. That's all. Watch, I'm going to explain. X here is what? X here is what? 2 here is what? 2 here is what? 5 here is negative. So they are what? Maybe O. They're opposite. That's what we do when people cheat in school. Because if you go that direction, you're going to end up with this. If you go this way, which I did, you end up with this. But both will give you the same. They're actually the same answer. Because if this x come over, it will come negative. If this x crosses the equal sign, it doesn't come negative. Yes. If this minus 2 crosses the equal sign, it doesn't come positive. Yes. And then you divide it by negative 5, in this case you divide it by 5, okay? Alright? Which means, let's see. Let's substitute now.
Yes.
What the question we have here with this? Let me see. 2 minus 5x. Let's use 3. Let's go. 5 times 3. 15. So 2 times negative. 15. Which gives you what? Negative 13. So your x is 3, your y, or your f of x is what? 13, right? So your x is 3, your f of x is negative 13. Let's put in negative 13 to this. Let's see what we get. Negative 13 minus 2 minus 5. You should be able to receive it already. That will give you what on top? Negative 15 divided by negative 5. Give you what? 3. So we have the reverse now. Alright, we placed in negative 13 and we found what our x was. Our x had to be 3. Okay? So you can get your y and you can find what your original x was. You realize? Because I started with 3. I started with 3 and I got negative 13. So if I have negative 13, if I do the reverse, I found that I have what? 3. You see that? The same thing applies to over here. Let's fit it in. 2 take away negative 13. If you don't want to put a bracket, it's up to you. You don't have to put a bracket. 2 take away negative 13. 15 divided by 5. So it doesn't matter which one you have. You'll get the same one. Answer. You see that? Good. Some of you like to transpose. I like to transpose to make my 5y positive. Some of you don't care, you just skip it, you just divide by negative 5. Kudos to you. We have calculators anyway, so you can't really make much mistake with the calculator. But I don't really use calculator when I'm working on stuff home. So I try to keep everything positive. As you can tell over here, you realize the other thing that's positive. So end up with positive. Over here, end up with negative over here. Alright, but anyway, we don't want to put negatives either way. So the inverse, I just proved that the inverse is what? Correct. So the answer is really this, eh? The inverse is this. It's the answer. I mean, that's the answer for the question, okay? That. Can I do one more before we go? The last one.
You can do it.
You don't take it?
You can do it. Make sure you catch the story that you.
You know? Oh, yeah, no, they leave it. Okay. Let's go past the last one. Let's go past the last one. Let's go class, the last one. Call it up for me. F of x equals a plus bx. Good. So just don't worry about this part. I'm trying to tell you that's how you're gonna look when you're finished. You're gonna look something like this. So what do? You write it back. You write it back without that. You want to know what you're gonna be. But I tell you how it looks, okay? Now as I told you, when we start out, we start with the outer shell. The outer shell is what? F of x, right? The outer shell is f of x, right? Yeah. What is f of x? What is f of x? 2 minus 5x. That's the outer. But guess what? The outer and the inner is the same what? Equation. So now, you put f of x on the inside to 2 minus f of x. Okay? Which is, what is f of x? 2 minus 5x. So, 2 minus 5, 2 minus 5x. If you want to skip this step here, it's up to you. This step could be skipped. You simply just put it in. It goes straight from here to here. Okay? So now what's going to happen now? What's next? Dominic, what's next? Yeah, go over this part. Give me this part. Give me this part. No, give me in steps. Maybe don't work it out, but give me in steps. That's good, you don't work it out. Give me in steps. Follow this. We're doing steps for those who don't know. What is next here? Somebody help her. Guys, next. 2 minus what? 10. Minus 10. Good. Okay, plus 25x. 2 minus 10 is what? Does this look like something up here? So if you put A down here now, put A here, and you put BX here. Clearly A is, and B is what? A equals -8, B equals 25. The trick with this, when I first saw it, I said, oh, they got to work out something with this now. Then I realized, no, they're telling you that's how it's going to look. As you can see, it looks that way. Yeah. I wasn't paying attention when I was watching it. I thought it was a new equation they gave me with A plus B. But I said, with that all variables, they're gonna number in there. They're gonna say, oh, the fact that the number in there, that means that can't be the equation. They must give some kind of number.
Do you have, F in bracket, what does that say?
F of x again, you went back the same formula twice. F of x. And F of x is what? 2 minus 5x.
Yes.
I'll read one more picture. This a little clearer, but she did perfectly. Okay? What we did last class is that I put everything in one. I gave you the composite. But what she's saying, which is true, and now I think back on the truth, I was going to teach you 2 methods, but I kind of deferred to the first one over the second one. What she did, what we do is, we look at the inner one first, right? Which is h of x. Okay, h of x. H of x is 5x. Everybody see that? So you ignore the f part. Okay, you understand? You know you're dealing with h of x, and h of x is in the inner part. Remember I told you there's an inner and an outer. The f to the left will be the outer. The one to the right will be the inner. You look at the inner, then you substitute. Okay? Which we found out this to be 1/25? Right, 1/25. Then she takes this and this are synonymous, or they are what? They are what? Equal. And if they are equal, they can be what? Into what? Changeable. The man showed us that in the video, so whatever. You understand? This and this is exactly saying the same thing. Because h of x is that formula. So what she did, she went here now and she partitioned this h -2 now becomes what? F 1/25. That something look wrong there? No. Because if this and this is the same, this could be removed and that go into the spot. You understand? Good. As a result, you're finding that now of f. F is 2 minus 5x. Right? So, basically, Why are we doing this x? Tell me. Somebody tell me what do this x? Or what would I do with this x? Substitute. Remember I said all we doing is really what? Substituting. Everybody see that? Good. Which could give us, we know, this will really be 5 over 1. So 5 to 7 goes 125 5 times. Gonna give you, what, 1 over, yeah, it will be 1/5. Good. I remember last class I told you, oh, you change this too. Why you put it to the 2?
Times the boyfriend.
It tells you by the denominator, very good. 5 times 2 is what? 10, and you give it back the denominator. Why? As this. She said she 10 over 5 here, minus 1/5, and they say you went down to the dark area. Okay? So then that gives us what now? 900. Let's go to 9 over 5. Another way of saying 9 over 5. 1 and 4 fifths. Alright, so very good, Dominique. Excellent. Okay? So, I don't know, whichever one looks more adjustable to your eyes, then you take it out. You got it? There we go. What we did choose there is that we took all of h of x and placed it in f of x. So it looked like this. F, open bracket. Some people use a square one to differentiate. They put h of x and do that. Anybody see that? So what she did, she substituted the number into the function h and she worked it out. This is a very complex number, by the way. CXC just tested you guys for this one. Right? And then when she found h of negative 2, she found what's the result of that now inside of f. F being downside. But what we did last class is that we put h of x into f of x one time, which resulted in the outer shell being what? F of x is what? 2 minus 5x. So where h of x number? Where x is, that's where you put your bracket now. I'm making me think of a big formula, but it's not a big formula. You just simply 5x. Now you can even go further and do this. Instead of putting x here, what we could substitute for here. Look at the formula, look up there, look at question 3. Negative 2. That's that? And where the negative 2 gonna go? Where anything in the equation goes, where? Wherever x is, that's where you put the thing you need to substitute. So substitution can happen nowhere else unless you see where the x is. Okay? If you realize something, you don't realize that now this gonna become what? That. You want to see that? Remember how we found this to become that? Anybody remember? Anybody remember? Don't tell me yes or no, because you say yes, I'll call you. Yes. I know I got you now book anyway, so 5 to the negative 2 is simply saying 1 over 5 squared. Okay? Anything to the negative 2 is what? Fraction. You understand? Anybody understand? Yes. And then 1 over 5 squared. What is 5 squared? 25. 25. Okay? Don't forget that. So this now becomes 2 minus 5, 1 over 25. But you have to put the brackets. Why have to put brackets and not leave it like this? Why have to put brackets and not leave it just like 5 times this? Like that. Yeah, look, it's a mixed number. So you need to include that. I remember a whole big 5 means really what? 5 over 1. Then I don't know more, because the rest will look like that. Okay? Let's start up here, sorry. Because that will cancel to give 1/5. Okay? Consider the following functions. We have 3 of them. Remember I told you, when you have 3, they're not going to use f of x 3 times. The next one in line generally is G of X
And then H.
and then H of X.
And then you
But bear in mind, they don't have to stick to that convention. Any letter could be used. And also, as we start off on the video, you might have HT. That means you only have to use X. You could put T there, and that happens when you have time graphs, where the X value is really the time value. So they don't put X, they put T instead. Okay? So in algebra, any letter counts. Here they ask you, for what value of X is f of X undefined? I'm going to give you a little hint. I don't think much of you might not know what the answer for that is. Huh? Go ahead. What's the answer for this? It's not just waiting.
Nah, wait, no.
What's the answer for 3 divided by 0?
0.
Take your calculators.
0.
Divide 3 by 0.
0.
So should we divide by 0?
No.
Why not? Is it not what?
Math error.
Math error. You know why? Because you're not supposed to divide by what the 0 represents. Can you divide by nothing? Can you bring nothing with you?
No.
Nothing represents emptiness. If you got a bag of nuts, you're going to say, oh, I have nothing inside. Just basically nothing. You can't have nothing. All the way saying. Nothing in there. You understand? So you can't divide by 0. When you could, yeah, you could. But I'm saying, 0 will mess up everything. You understand? So then, if that is the case, look here. We have 3 over x plus 2. I need everybody to pay attention. If I put a 1 here, what would it be?
Geometry.
Good.
G1.
Which is 1, right? If I put a 0 here, what's the answer?
3 over 2.
3 over 2. Or 1.5. Good. If I put negative 1 here, what's the answer? Giovanni, let's go down.
3 over 1.
3 over 1, which is what?
3.
If I put negative 2 plus 2, what happens? 3 over the same 0 we said we should not use. Because 0 represents nothingness. Okay?
You should have unpacked that there, sir.
Yeah. No. I'm giving you context. So then what would you say? What is the only number you recognize? If I put negative 3 going 1. And negative 3 plus 2 can give you 1. Negative 1, which will give you negative 3, you catch? So what number is problematic if it goes below the divide sign? In this case, negative 2 is problematic. Why is it problematic, somebody? Encourage me, be quiet. Thank you. Because it's going to result in another 2 being added to it and it brings it up to 0. And we can't have, or we don't want, so we don't want what? To have a 0, because 0 is the only one that doesn't work. Am I getting me? 1, negative 1 divided by 3 gives an answer. 200 gives an answer. But this partial 0 giving us back what? 0. So when you see things like that, look in your denominator. Write that for me, please. Look at your denominator. Tell me what you see on the tree. What is in the denominator? X plus 2. So write x plus 2 and you have to set it to 0. Why? Why did I set it to 0? Why did I set x plus 2 to 0?
Because
Find value of x.
We know X.
To find the value of x, we need to know what can be added to 2 to give us what? A 0. What you say you're coming, sorry?
You don't say.
Oh, sorry, I didn't understand that talking about. I thought it was a Spanish
No, I was telling you that.
Okay, say it again for me. I want to hear it in the camera.
No, it's okay.
It playing by the way?
Yeah.
Alright. We're saying we need to find what is the problematic number that, because 2 is already there, because plus 2 is already there, we need to know what number 2, when added to, will give us 0. Because we don't want to end up with what? We don't want to end up with what? 0 under here. Under here is actually called the divisor. You understand that? So we don't want 0 to be what? The divisor. You divide it with the 0. Okay, so then this is what you do now. X equals -2. What did I do?
You pass over.
Okay, over. So then this is what you do now. You take a line and do this. X cannot be -2. Next, let me use another word. X should not be what? Because if x is -2, it's going to muck up the equation. You understand what I'm saying? So that's what, it's just what CXC expects you to do. And you could do that mentally. This is the working really. All that was to give you context. But this is the working. X cannot be -2. Now let's switch it up then. Let's make up another thing. Let's put 4x plus 5 on top over x minus 3. What x should not be, because we don't want to divide by 0 or with 0. 3. Because if 3 is here, 3 minus 3 gives us what?
0.
0. And then you divide 0, 0 mess up everything. Okay? Can I give back 0? Calculator is working. You understand? You see how quick you guys say 3 for this? So, 6 you're going to do it mentally, but technically you're still supposed to do this. What was x minus 3? So technically you're supposed to do this. X minus 3 equals what?
0.
X equals what? 3. That means x should not be 3. Simple. Simple maths. Okay? Jamante, you can understand the board. Is that right? Corinne? You have 2 phones? Yeah, that's for the second phone.
I'm in your business, you do what?
I know which phone we done baby. The business phone and the friend phone. Anybody have that? Don't take an ear or something for that, guys. And those who already finished that, let's look at the next question quickly. You guys better thank God that you didn't put f of x for this. Because if f of x was for this, the quarter would have to go here. I would have had a quarter underneath that, but that is a problem for me. But for some people don't like fractions. People don't like walk-up fractions. So they put g of x instead, which is a linear equation. Yes. Well, we don't mind the 3 on top because what happens is that once down here end up to 0, nothing else matters. You get what I'm saying? Yeah, so you can when 3 could be on top, you got 3 gonna get something here. 4 times 3 is 12, 12 plus 5 is 17. But guess what happens if 0 still gonna be to the bottom? We even know we ain't gonna keep at the top because you know result is the what? 0. So that's what they say. When you see that undefined, that same thing that the calculator give you. What you can say the calculator says so? Math error. Right? We want the math error. Alright, so what number can I use? All the possible numbers in the complex world of numbers that God created. In that equation, only one number can be used. Which is what? Which is what, class? No. -2. Because -2 going to make down here, the denominator becomes what? 0. The 0 is what we don't want to end up with. But what made it 0? Here you have negative 2 plus 2, okay? Good. G of a quarter. Who want to come to the board to do G of a quarter for me? Anybody willing to try that? Always write the formula first. Then what you do? You substitute. Now, don't expect CXC to give you nice numbers all the time. And do not run from fractions. Do that. So what's next? Help me out somebody, what's next?
This, the one next?
Yes, what's next?
4 times a quarter.
4 times a quarter minus 5. You should know, if you got 4 quarters, you think about money, you got 4 quarters. What you got? $1. So 4 quarters. You have 1 whole. You have 1 minus 5. You ain't got to even work out that. You don't have to do this. 4 over 1 times 1 over 4. And then 4 is 4. And then 1 times 1 is 1. No, you're not going to do that. 4 quarters give $1. Alright? 1 minus 5. Negative 4. Alright? Bada boom. Finish. I don't know what the next question is talking about. Yes. Oh, H. Negative. H bracket negative 3. Okay. Everybody let's go. H negative 3 is next. So write down the formula. I need to write down the formula first without any changes. X squared plus 1. Then I write it back with the substitution. This is nice, but this one it looks so bad now. Now watching it. Watch how quick this one was. This one was quick and easy. Shakira, let's go. Stop here. Shakira. Since you call Dominique up to the board, you come. Help me out. Shakira, let's go. The formula is there, x squared plus 1. What's next? Yeah, watch over here. We don't work out this man. What you know here for me? You in La La Land. You're an Alice's friends. In Wonderland, let's go, man. Come on, you're Alice's bosom buddy, man. Shakira does substitute it.
Yeah, me know watching that today.
If you don't watch it over here, are you in class today? Somebody help me for me, please. I don't have.
Negative 3 squared.
Negative 3 squared plus 1. You could write negative 3 squared like this, or you could do it like that, but be careful writing it like this. Because sometimes in a calculator, the calculator they treat the minus as separate from the 3. The calculator they treat it like this. So I will advise you, learn your calculators. Use bracket a lot. So although I write it like this, don't write this in your calculator. Somebody test it out for me. The calculator going to treat this as a minus here and I'll give you back 9 there. And negative 3 squared is not negative 9. Negative 3 squared is what? Negative 3 times negative 3 and negative is what? Positive. But it is the same, it is true. Right, so, and if you ain't paying attention, you'll run away with the negative 9 think you're doing something right. Not realizing how the calculator thinks. So I teach you something new today. Okay? So remember that, you put a little bit more easier. And X like that, okay? So you don't want to use the bracket to help some people. Okay? Negative 3 in the bracket, you square what's in the bracket. Plus 1. Shakira, negative 3 squared.
I'm name. Positive name.
Okay, give me the full answer now, Shakira.
10. Positive name.
God bless your soul. That's why I've been putting in front of this spot. You can't get negative 9. That's what I tell you have to use brackets. Okay, so your brackets here, see brackets up here. The person was bracket, put minus 3, close the bracket. Let's speak here. Hey. Thank you. Alright. Wadisha, I don't think you get it there. Other than that, so let's focus. Something about maths, I'll tell you. If a concept is not gathered or caught at a certain time, it could take you years to catch back that concept. Especially when time runs on you and that concept has not come around the proper way to you, then you could digest it, ingest it, and digest it. When you get a chance to get proper teaching, don't try multitask. Okay? Now, I hear women can multitask very well. They can listen to music, wash dishes, and cook all at the same time. But they design that way. I need to focus. Alright? So kudos to all you. Kudos to you. Right? But nothing better than if you're focusing. You have somebody talking to you, like, you know, somebody, a guy can propose to a woman and you know, he doing all kind of things and not focusing enough. She can think, but he got to hear the publisher. Hey, focusing on what you have to say. Stop what you're doing and focus. I will hear parents and sisters do like that. Right, so let's focus there. Let's scroll and read and act like as if, yes, focus, let's go, let's focus on the board, guys. Okay? Now, what was Dominic method? Anybody remember what it was? What it was? The inner plus. What's the formula again? Can I rub it up again? F of x is what f of x.
3 over x plus
3 over x plus 2. Bearing in mind, that x can't be what? Why not? And we don't divide by 0. Good. That's a little quick history check. Good. So we have this. So Dominique says, do that first. Then you substitute. Start writing for me, please, the 0. So 3 over 0 plus 2, which is really what? Actually, we did this already, isn't it? I remember we did this already?
Yeah.
Right, which is what? 3 over 2.
Another answer.
That's it. You don't have to make that into a big number. But then, now, so f of 0 gives us an output of 3 over 2. You now substitute that back into the outer now function, and now we have what? 3 over what? 3 over 2 plus 2. I need some space, so I'm going to go up a little further over here. I need a better map.
One thing.
Maybe we try to make it. Your OCD.
You need to put them one side.
I'm messing with your OCD. Pardon? Remember talking about this, when you have one being a fraction and one being a whole number?
You multiply the whole number by the next denominator.
But why not the denominator? Guys, I want to hear you coming, it's going good. What is supposed to do?
You don't let it go me.
Multiply the whole number by what? The what? I hear something about you.
He said denominator.
I said no for the denominator. You multiply the 2 by the numerator.
What?
Oh no, sorry.
Tell me say it right the first time. And I say it right the first
And I
time.
edit, so don't worry.
Yeah.
You multiply the whole number by the denominator, so you were correct. Say yeah, people. Alright, let's go.
Watch yourself play me now.
You're correct. I just was testing you guys.
Okay, I like that. You know Remember, hush.
So it'll be what? 2 times, which is what? 4. And then you put back what? The denominator. But see that? Everybody understand that quick technique? Just multiply that by that, and then you put back the 2 on board. Because you want both of them to have the same.
Denominator.
And just back check in your mind. Is 4 over 2 equals 2? Yes. Am I agree, right?
Yeah.
4 divided by 2 gives 2. So I'll back check your work. Good. Now you can add because you put the add fraction that have the same denominator. We got a problem with the 3. What else? 7 over 2. What else? Very good. This divide sign, we're going to write it a different way. So 3 divided by 7 over 2. You see that? 3 divided by 7 over 2. Next. Next. Yeah, change the first one first though. 3 over 1 times 2 over 7. Good. There's nothing to cancel. So the answer is what? Can that be broken down? Of course not. 7 is a prime number. And if you can, then be able to do that, okay? Good, so let's go. Quickly. So that's the Dominique method. Alright? You're written history now, okay? You put the 0 in, you substitute the 0. Then you realize that gives us 3 over 2, which is a fraction. You take that and put it in the next formula, which is still the same f, the outer one. And we got this. Then this led to this. Right? 2 times 2 is 4. Going back 3 over 7, 3 divided by 7 over 2. Always change that to the other direction, the other way. And that's that, okay? That's the Dominique way. My way now. Take it down. Everybody, going too fast? What time is it? 6:00?
6:40.
Okay, let me do this quickly, then we're going to do this. The last question, B? No, okay, let's go quickly there. My way would be F, I put X first. Before I substitute the 0, I see to see how F going to look within F. It's going to look quite nasty there, because we're using fractions within fractions, okay? So I think Dominique method might be the better method when you come over with this one. Alright, but I'll still show how it looks. So 3 over, we put bracket, we put the X, X plus 2. Oh yes, put the bracket, yes. Alright, here we go. We put f of x first, is 3 over x plus 2. Then you put f of x. We will put 3 open bracket, which is 3 over x plus 2, close bracket, plus 2. Okay? So this is 3x plus 2. But in the x, you still put back 3 over x plus 2. Okay? I'm going to need a little space, why? A little space too. Okay, let me say put it here. Now we substitute the number, which was 0. So you simply put this down. 3 over 0 plus 2 plus 2. You're going to start to see shape out. You're going to start to shape out. You say, my method is keeping everything in one spot. Alright? Then what thing going to happen here? Right, so 3 over 2 plus 2. But I realize something what we reach. That's it. We reach right there now. And many things should go any further because, yeah, this is the next step after. So may not do anything again. Okay? I don't reach this step. Okay? So, but I would advise you though, this could kind of confuse your eyes. So I would recommend work out the inner one first, do the outer one, put the inner one, I think put the inner one, put in the outer one, and then you find the solution, okay? You got the video. What is G of X again, guys?
4x minus 5.
4x minus 5. What is H?
H x equals x squared plus 1.
Oh, this is looks simple for today. Okay, good. I didn't remember, I thought it was the how the fraction.
No, I just want to do the expression simply.
Okay, good. So we'll start off with the inner. You understand? The inner is what? H of x. Have you kind of like already? Write it back. This is what I do to keep myself in check. You write the inner first. Dominic, let's go. Start with this. Let's go. Write the inner first. That's it. There is no number to substitute. Can I say to what?
Simplify.
Right, that means simplify then. Can you see? Start writing this.
There we go.
What color do you think? This is Canada? Let's go. Then you put the G of, you put a big bracket, like a square bracket, H of X. So you write G now. What is G?
4x.
Wait. G. Wait, oh yeah, G's up here. Oh yeah, good. 4.
4 and then.
We got to open the bracket.
Yeah, 14. Yeah.
Now 4x minus. Right. So what is H of X? H of X is x squared plus 1. Again, Kalanji said it earlier this afternoon. What process is this? Distributive law. Okay? Let's go. Distribute them. Can Daisy do that for me?
4x
Squared plus 4. Excellent. Val, fix that last part there for me. But you keep the same for you said your this is a 4x squared. Yeah. Minus 1. Alright. Now I'm gonna get a joke. No, that's not it?
No.
We did this year. And there were 3 of them. I'm gonna give a hint. I'm gonna give a word. I'm gonna give a word. Let me say that trigger you. It's perfect, but look at what is this. What's the other side is? So it's a difference of, start writing for me guys, 2 squares. How do we know there's a difference of 2 squares? The subtraction sign is 1 and the square of the x, and 4 is a square number. Remember, 1 times 1 is 1, 2 times 2 is 3 times 3, 4 times 4.
16.
The next one is what? 25, 36, 7 times 7 is 49. The next one, 64, 81, 100, 121, 144, 169, 196, 222, 50, 50 is what? 225 or 250?
You never show us everything.
59.
Okay, good.
What?
I feel somebody gonna bang me up, but I don't get it. Remember, I said 1 times 1 is what? 1. So 1 is also a square number. Then the convenient, you leave it off, but you go chuck it off because remember the property of 1. Please watch this for me. Everybody stop writing. The property of 1 to the 0 is the same as 1 to the 1, which is same as 1 to the square, which is same as 1 cube, which is same as 1 to the 4th, is same as 1 to the 5th, so. Okay? What am I saying? N to the power of 0 is 1. N to the power of 1 is itself. 1 times 1. 1 times 1 times 1. 1 times 1 times 1 times 1. You can see me now? 1 is unique, so if the power on 1, you can choose to put on a 2. Hence, that's what the 2 go there. So 1 times what? Give me 1. 1. What times what? Give me x squared. X. And what times what? Give me 4. 2. Next. We did this year. Let's go. Two x, 1, 1, 1b plus, 1b minus. Thank you, Telanji. Okay? Can I ask a question? Can this be the minus and this be the plus? Yes. Don't forget that. So just choose which one to be. Remember, what changes is the second number. The second number is either positive, one be positive, one will be negative. But the 2x ain't going to change. 2x is just positive. Okay? You understand? It's opposite. So, you finish. Well, you finish?
Yeah.
Not necessarily, you see? 2x times 2x is what? 4x? 2x times positive 1 is what? Oh no, you go back to this, yeah, you go back to that. You finish, yeah, you go back to that, yes. What's saying? I need an inverse. Pass it. Right, let me ask the question again. Alright. What the first thing we do when we find the inverse? Wow! Set the function to y. Alright. And we saw it in the video just a while ago. They mean the same thing, okay? But we want to just work with y and x and y, okay? So that's the step one. You should have that in your book somewhere, step one. Change the function to y. I'm going to send a video tonight about that to show you how to do the inverse. I didn't send one. I sent the basic ones recently. Hoping you guys watch them. Now I'm going to send some more complex ones that you could just delve further, go beyond me. Don't wait for me, because if you wait for me, you ain't going to pass CXC. Go beyond me, please, okay? Good. Next step, after we change this to that, simply that, if I was back in high school, you get a quick math. Next step is what? Y. You can say switch, or some people say interchange. Make x, y, x, and make x, y. Next step, you transpose for y. Sounds meaning you're gonna answer, but there's something missing, so or you do want transpose, okay? So my transpose are everything today? Let's go.
X plus 5.
Very good. She said 4yx plus 5. Excellent. Both of you are correct. All of you are correct. Okay? You carry 4y on the other side there? Right. So at this point you can switch it around to put 4y equals x plus 5. But I tend not to teach that sometimes because when people start to switch around too quick, they start to confuse themselves. Right? But if you could do it, there's no problem. You can do it to keep it that way, okay? But she's correct. You could now, at this point, put this over here, that over there, and then the 4y would now be on the left side. But it's inconsequential to me anyway. We still think of something. Because we have that for y. So what it could be?
So it will be x plus 5, it will be x plus 5.
Very good. You give me the reason, but they just give me the answer. So both of you are correct. You give me the reason why, but they just gave me the answer. So very good. You are the same track. You know about that table? Good. After you reach here, you are finished. This y now have a new a new symbol. You change it back now, that f with the g. G inverse of x, and that those two are saying the same thing, okay? Those are saying the same thing. You have to now put that new symbol, the inverse symbol, and then simply write back this. But some people don't do it, they switch them around too. You can switch it around, they look better coming this way. Would you agree? So you can simply switch it around. Don't show the same thing. Now, from here, what's next? Look at the original question. You're solving. But it's doing what? What is function now we said they do? It's substituting. Okay? So we substitute G inverse of -2 now equals, I need this piece out, I left it up, but I left it up now. Let's go, somebody help me out, what am I here? -2 plus 5 over 4. 5 take away 2. We finish. You really, how I say that? You really, I don't say -2 plus 5? I never say -2 plus 5, so people start to think. So if I say the opposite way, if I take away 2, and you don't know if I take away 2, then I don't know If you went to school in St. Kitts, okay?
Something like that, the one that don't have a bigger number, carry the sign.
People don't teach that, yes. I don't teach it that way, but yes, people don't teach that. If that's the way you remember the problem, and it is, I think people to consider money in their head. Your husband $2, they have for it. You're not going to treat them. Because you pay everything, you're going to treat them. Yes. Oh, come in. Come in. Hey, stop the video, stop the video. Hey, stop the video. Okay, good afternoon, everybody. Alright, the first question asks is, the first question asks, what is the coordinates for x intercept? X intercept. In other words, for what line, sorry? X intercept for line L. We have line L, we follow the line, we do the intercept at 6, 0. Okay? Now they're asking for the what? The Y intercept? Y intercept for line M. Well, M, we follow it. The line intercept is what? What are the coordinates? 0 for the X, go down to -2. Right, excellent. X, Y, X, Y. Go to the okay, so those two spots are what we are looking for. But that's the first part of the first question. Very simple. When you're giving an intercept, there will be a 0 somewhere in the coordinate, okay? There will be a 0 somewhere in the coordinate. Next question asks now, asks what?
Equation of line.
Uh-huh.
The equation of line L is x plus 2y minus 6 equals 0.
Find the value of
Equal 0.
Find the value of what k given that the point
Oh,
Is line
is 9k.
lies on the line L.
okay, so you're looking for 9K. Well, let me just scroll up. I could scroll up. Everybody have the.
Yeah.
All right, you can take a picture of this quick then. And then I could have scrolled up to the other. Okay, so we have it. X plus 2y minus 6 equals 0. I want to get that. What? X plus 2y minus 6 equals 0. And they give you you 9, comma k. You have 9, comma k to work with. Now, this formula is not written in the linear way that which normally we use, okay? Who can remember the formula for linear equation? Do you remember? What's the general formula that we have for linear equation? Y equals mx plus c. Good. So clearly, this has some transposing to do. Would you agree?
Yes.
So we have to do some transposing with this. Somebody help me transpose this, please. Clearly, what should be alone on the left side? Why? What's supposed to be somewhere in the middle attached to X? What do you call this M?
Gradient.
The gradient. And the last number will be what? The Y intercept. And we just found some interceptors now. Okay? So you should already know the intercept for L. Well, they give you the X intercept. But if you look at the diagram, go back to the diagram. What's the L? What's the Y intercept for L? If I look at the board, the split is too far. What's the Y intercept? For L, yes, L. 0, 3. You see that? So the diagram, the graph is telling you that the split is too far. Elson? Oh, no more change, you know? Okay. Come up, please. Come up. I'm not begging. I'm demanding. Good. So we have to get this to look like this. Somebody stand me up quickly. How do I transpose this? What do you going to put on the left side? We just establish it. We just set it to go.
The
Y. So good. So we're going to leave 2y by itself. Send everything on the other side. Which will be what? Make it look like this.
X, 6 plus 6.
It's close. Something is missing.
Negative X.
Negative X plus 6. We cook it on gas. Something is attached to the Y we don't want.
We over.
Good. So then Y equals what?
Negative 2x plus 6.
Over
2.
2. Now this is the stage where people need to understand where we have a bar or each term can have its own 2. That's why when I teach you fraction, I teach you both. For you to realize that you could have one bar or each could have their own bar. So somebody help me out, somebody separate these having their own bar. Negative what?
X over
Negative X over 2. I realize some people think of that in French.
plus
6
over 2.
Good. We put the negative in front. Good. Now, I don't know if you remembered when I showed you this. Negative X over 2 really has a coefficient in front of the X. What number is in front of the X? A 1. So if the X drop off to the side, what would we have now? Who could tell me? Negative 1 over 2 X. Am I see that? So negative a half X. So negative a half X plus.
3.
Did we establish that already? Did the diagram tell us that we were intercepting L into 3?
Yeah.
Let me go back up for those who wasn't paying attention. What should the 3 be? What's the L? Follow the L. The L came through the Y intercept where?
3.
0, 3. You see that?
Yes.
So you should have known that. So that's a good way to back check to know you're on the right track. Okay? You're on the right track with that. Okay? So then what's the gradient? What's the gradient, class? Negative a half is the gradient. Okay. Good. So basically, we are finished actually here. The y-intercept is 3. Alright, what the question asks? Find the value of k given that the point 9k. Good. So now you do your substitute. Wherever you see Good. You substitute, where you see y, you put what?
Okay.
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 And when you see x, you put 9. How we work this? Somebody. I want to take me to 4.5 now. Keep it as a fraction. Very good. Afternoon. Negative 9 over 2 plus 3. Remember I taught you a technique last class? Remember the technique I teach you last class? When you have a whole number and a fraction and the denominator, what do you do? Who remember? Everybody remember the technique? I need somebody to remember the techniques, you know. Multiply the whole number by the denominator. What do you know? Everybody? So 2 times 3 is what? So we end up with now, it's losing your juice, right?
And you put it in.
K equals negative 9 over 2 plus what? Maybe the closest one. I don't think you can't remember that fact once. Negative 9 over 2 plus 1? 6 over 2. But if you think back already, we had 6 over 2 already, we had 18.
Yeah.
You see? So we know we are on the right track. Okay? So you think K gonna be? Negative 3 over 2. Alright? Yeah, sorry? You could do different, yeah, there's different ways to do it, yeah. Normally, when you put it in as a coordinate, so if 9 is here, negative 1.5 goes here. Remember, negative 1.5 is here, you're saying
Yes.
3 over 2, okay, man, understand?
Yes.
Good. There's another way to do it as well. Sorry. Right, as I was saying, if you look at what they asked you for, what is the y for the x coordinate 9? You simply go across, we realize the last number was mentioned is 8, but common sense will tell you that the next number will be 9. When you look at 9, you say, well, what do y coordinate mean? Well, let's see the contact when they touch. Both of them touch here. When you look at here, this is negative 1, and this is halfway. So clearly 1.5, okay? So negative 1.5, which is negative 3 over 2, okay? So that's another way we could have recognized what is the coordinate for K, okay? Well, the next question I asked you, by the way, let's go quickly.
Find the equation of the 9m.
Sorry? Find the equation of
9m in the form of y equals mx plus c.
oh, I was to show you something, yes. Well, see, ask it here now. I was to show you something else. Sorry. You know good? What was it doing? Find the equation of the line M in the form y equals mx plus c. So you see, give it here. Okay? Just to say something now. There is another formula you can say on the internet. There's another formula you say on the internet. I think it's M equals y2 minus y1 over x2, x1. So I'm going to leave off the 2 and put 1 and 0, but it's the same thing still. If you transpose this to the other side, then it becomes times n, and y2 minus y1 remains on this side. This also can be used. Okay? Now, is that right? What's the gradient for L? What's the rise? 1, 2. So we have rise as 2 still. But what the run is? 1, 2, 3, 4. That means this is what? A half. Okay, good. So this is supposed to be a half. What? Okay, see the answer here now. 9 minus 6 is what? 3. Right? A half of 3 is what? A half of 3. 1.5 or 3 over 2. 3 over 2 or 1.5. But we realize this, what we had was negative, right? So who can tell me why this doesn't have a negative, but it need to be negative? Who can tell me why? Remember the answer we got, that the gradient, the k was negative a half. We just had it on the board. But we didn't get negative a half here. Why is that so? Huh? This line is what? It's a negative line. So in a case like that, we should have put minus 2 here. Okay? We should have put minus 2 here, which will result in what? Minus what? A half. I want to buy watching these things, you know. That will now give us now good. Just give us negative 3 over 2 or negative 1.5. Okay? Some people don't count it as 2 down, they just put the number and then what is a negative graph and then just tack on the minus sign. You can do that. If you're not going to remember that, just remember if you went down, then that down represents negative 2, which gives a negative a half, which gives us now negative 1.5. So what I'm trying to show you that this is another formula you could use. If you realize something, this is the gradient formula. Okay, this is the gradient formula. Small m represents gradient. There's another m in maths, which is the midpoint. That's a capital M. I'm going to do that today as well. So we have 2 ways, actually 3 ways we could have found it. We could have used the graph, we could have used this formula, or y equals mx plus c, actually 4 ways, or as Val and Calandra did, they simply just substituted into the formula which was given, and therefore, okay. There are many ways to attack. Okay? Either way, all of them before okay. So we picture. All of them. You realize something? Because we made mistakes previously, we don't already know what's the gradient for m. What's the gradient for m? 2. Remember see that? So the mistake was all in the loss. So if they say y equals mx plus c for line m. For line m. We don't have the gradient, so we don't work it out to be what? Good. 1 here and 2 here, which is what? 2 over 1 x. Right? What is the c-intercept? What is the y-intercept? We found that what's one of the first thing we found? Right? 0, negative 2. Right? Which will be negative 2. So y equals 2x minus 2. Come on. Right, so that's the simple way of doing it from the graph. But if you're going to use the graph in CXC, I will advise you to show them what you are doing. Because they can't read minds, CXC can't read minds of that day. CXC how could you use the graph? That's where you get this. Okay? So things like that, just use the table for some. Things you do, you take the 2 from here, you put what? Rise over what? 1, and put 2 over 1 in the 2. Once you do that, then now you use the graph. And you highlight that on the graph as well, because the graph paper is yours. Okay? That's one way. Another way is to find the gradient. How will we find the gradient? Somebody help me out. We don't find the gradient that way. But say we did not have a graph. Say the graph was there. How will you find the gradient? Huh? Which 2 points you use? You could do that too, yes. We could also use this as well. Give me some coordinates. I would guess 3, let's see, 3, 4 would be a good one. So let's go 3, 4.
-2, 0, -2.
And 0, -2. We got that from the y-intercept. Remember I said that?
Yes.
So now you make one x1, y1, x2, y2. You fill them in. Let's go, fill them in for me now. -3,
-2.
-2, take away 4, right, 0, take away 3. What's the gradient? -6. What's the gradient? Huh? What's the gradient? +2. Remember we don't find it here, you know? Remember we don't find the gradient to be 2. So we're looking for the loose change. We don't know what it is. Okay, I'm showing you that you could use the graph. You could use the graph. 1, 2. I'll just put 2. You could use the graph or you could use the gradient formula. Alright? But I advise you in exams, if you use the graph, it indicate that you use the graph. Okay? You understand? So we done find the 2 already. And how do you find y-intercept? Using algebra. The formula good. Y equals mx plus c. Pick any 2 points. So you have some points here. So you have some points in class. Pick any one. Which one you will pick? The 3, 4 or the 0, -2? Why would we pick 3, 4? Because they are positive. Try to use positive numbers, okay? Somebody help me. What is y? 4. What's the gradient? We don't find the gradient. 2. What's x?
3.
2 times 3. So 4 minus
6.
equals c. What is c? Good. Alright? So I've showed you how to use the graph. I've showed you how to use the formulas given to you. This is the gradient formula. To find y-intercept, you simply substitute a point, substitute the gradient, and then you transpose it to find what? C. But if they give you a graph, the best thing to do is to look at the graphs, negative to them. Okay? So the question I asked you for this is what the question I asked you for. So you take everything you find, the gradient, the y-intercept, and you make a what? Formula. Y equals mx plus c. Yeah. Alright, so keyword here is perpendicular. Perpendicular means The lines have to intersect at 90 degrees. Don't get accustomed to seeing things in one orientation. Get to see things in a different orientation. Now, those who are in high school should remember this. There's a formula. When two lines are perpendicular, there's something about the gradient. Gradient 1 times gradient 2 equals -1. Let me repeat. Gradient 1 times gradient 2 will equal -1. But what's the gradient of L? What's the gradient of L? -1/2. Or the gradient of M? Of M, yes. 2. 2/2 are what? So 2 times a half is a whole, and negative and a positive is what? So we prove it? So that means L and M are, again guys, this show that L and M are, because the gradient of the first line times the gradient of the second line must equal -1. And we just proved that. Simple that. If you multiply them together and get a different number, then they will not be one. So they learn something today. Okay? So perpendicular, for example, let me get a quick example. Say I say one gradient is 1/3. 1/3 times what? Give me -1. What times 1/3 give me -1?
3.
Very good. Yeah, I really something. These are reciprocals of each other. 1/2. If you upturn 1/2, what do you get? If you upturn 1/2, what do you get? A 2/1 is the same as saying what, 2, right? So if you upturn 1/3, you get 3/1. So all I have to do is find the upturn number, but one of them have to be what? So then this has to be negative. Okay, I see that?
Yes.
So let me give one then. So what's our gradient here is 5 -5/6 times M2 equals -1. What M2 has to be? 6/5. I see that now? I can prove it. Whenever a multiplication and a fraction crosses, it does not go to divide. You keep the multiplication sign and you're what? You're upturn. Remember that. So M2 will be now -1 times 6 times, sorry, -6/5. And guess what? A negative to the negative is what? 6/5. You see that? Please remember, when you carry over a fraction and you're multiplying it to carry over the equal sign, normally when you carry over something, if it's time to divide,
Yeah.
with a fraction, you don't divide. You still multiply, but you upturn the number. Now remember, within the fraction is already have a what? Within the fraction already has a what? Guys, I lose now? I'm saying, whenever you carry over something by times, it normally comes divide. But when you have a times and a fraction, the fraction still remains time, but the number what? The fraction what? Flips. And I say to you, it's still similar because what? Within the fraction is already a what? A division. Okay? You still follow the rule that you don't divide by fractions, you multiply by its what? Reciprocal. So this will be 6 over 5, but it will be positive because one has to be negative, the other has to be positive. Remember see that?
Yes.
Good. So that all of this is just saying that. Just make sure they match up based on it being reciprocal. They have to be reciprocal of each other, and one will be negative. If the first one is negative, the other one will be positive. If the first one is positive, the next one has to be negative.
Can you repeat again? Why is it that it didn't change on the next side?
I can show you. Let's keep it that way. Let's use it as divide. Let's look at it. Negative. You just write it with it. Negative 5 over 6 times m2 equals negative 1, right? Normally, when you carry over something, you put divide, right? Let's put it then. Let's put negative 5 over 6. Everybody watching?
Yeah.
You normally say, the times becomes divide. But watch this now. Negative 1 divided by negative 5 over 6. What is happening here? Negative 1 times negative 1. Remember, we don't divide fractions. So, you realize now it comes to times? Alright, so, to make a long story short, when you carry it over, just flip it one time and keep the multiplication. You understand?
Yeah.
That's the reason. Because when you divide by 5 over 6, you can still have to upturn it and multiply. It's still going to be negative 1 times 6, negative 6 over 5. Okay? That's a rule that people don't remember. Fractions is just a little slightly different. Go ahead and take a picture. And the last one, before I get your break. Okay, I could break it. Line L and line M represents the graph of a pair of simultaneous equations. Use the graph on page 11. Write down the solution of the pair of simultaneous equations. I'm going to show you two ways, but this is use the graph. That means you must just watch it and see the answer, and I'll show you how to get the answer. Okay? So I have to clean the board. Everybody have this? This? No, that was just a little explanation. You don't have to worry about that. But come we took a picture of it anyway. She took a picture of it, so I put it in the chat. It's in the chat. Okay? So use the graph. Now look at these two. They look perpendicular to you? They look perpendicular to you? In a sense, yes. If you take a protractor and measure it, you should really see you'll see 90 degrees. Okay? And where did they intersect? They intersect at what? 2 and 2. That's it, that's the answer. Right? Whenever you have simultaneous equations is telling you what number, what coordinate is unique to both lines. There's only one point that is unique to both lines. One, whatever this number be, is not on M. 2 is on both M and what? L. 4 is only on what? On L. 3 4 is only on what? M. So the only point that satisfies what? Both equations is the intersection. So put something on it for me, please. That is the common point. 2. I have proved to you by using simultaneous equation that is the answer. Okay? That's the answer, 2 T.
We were supposed to, we just want you to find that.
But let's use the graph.
But I think because you have a space, so I will call it 2 is supposed to wait.
Yeah,
Okay.
come on. Well, but that's for practice sake. That's for practice sake. Let's go. What the first equation was? Negative a half x minus 2 or plus 3 or something? Plus 3, right? Next one was what? Jandy, let's go. Let's go, Jandy, you know what that was? 2x, take away 2. So this was what? Which one is this? L or M?
That's L.
This L, and this is M. I should know this is L because they have a negative gradient and this is a negative line. Okay? This is a positive gradient and this is a positive line. Okay? You see that? This is just for revision's sake. Okay? This is not to do. But if you did it for revision's sake. We're gonna set both equations to each other. Now why would I do that? If two equations both equal to y, you're simply saying that two of them are equal to each other. Because if y equals this and y still equals that, that means this has to equal that. Would you agree? Would you agree? Let's see. 2x minus 2 equals y, and y still equals a negative a half x plus 3. You see that? I say something wrong here? Because this equals that. Well, this is still y, so this equals that. And if that equals that, then that equals this, okay? Good. So then we're going to write it back, start writing, and we're going to simply move the y. Let's transpose, then this up, bring over negative half x. Huh? Right, so give me 2x plus huh? 2. Good. 2 plus 3 is what, class? 2 plus a half. 1.5. Well, now we want a mixed number. So let's make it into a improper fraction. What we're gonna do? 2 times what? 2?
2 times 3 is 4 plus 1 is 5.
So it'll be 4 over 2x plus 1 over 2x. Which gives you what? 4 plus 1. Huh? 5 over 2 x. I just teach you something. I just teach you a rule. When a fraction goes on the other side, what do you do with it? Huh? And you keep what operation? You keep the multiplication while you what? You flip the fraction. So you'll be 5 times what?
2 over 5.
Good. We'll make the 5 over 100 again. Let's just save us a lot of trouble. So you think x is? So you don't get 2 already? See x is 2? The base of that?
Yes.
X becomes 2. Now in simultaneous equation, what do you use a 2 for? In simultaneous equation, what do you use a 2 for? If I found half of the equation, half of the point already, sorry. We just found x. We have to now substitute. Very good. Substitute where? Whichever equation you choose. Choose one. Clearly, it's an easy one there. 2x minus 2 is the easiest one to use. Okay? So you substitute x equals 2 into equation y equals 2x minus 2. Simply put it in now. Y equals 2 times 2 minus 2. 4 take away 2 y equals 2. So we get the x is 2. X is 2, y is 2. Okay?
Take 10 minutes break. January 2025.
A line, okay, let's go guys. Carry on. A line segment, that's what class mean. A line segment joins points C, -5, 6, and D, 7, 2. Calculate the midpoint of the line segment CD. Now, the formula for midpoint. Am I going to tell you the formula for midpoint?
M bracket.
Big M bracket,
X1 plus X2.
x1 plus x2 over 2, big comma,
Y1 plus Y2.
good. Now this again, we are strong man. Let's go x1, y1, x2, y2. You get the code down now. You got it down now. Am I see that? Let's do some substitution now. Jandy, you're gonna help me. Jandy, you're gonna help me. Stop me up, Jandy. With the camera on, with the camera. Jandy, let's go. -5. Thank you, Jandy. Jandy, let's go. Y1 is what? Huh? 6. Y2 is what? Good. Let's go, class. Look at the 7 plus 5. So 2 over 2. And 6 plus 2 is what? So we finish?
Yeah, me.
Which is what? Good. What does midpoint mean? Middle, halfway, center. This is a capital M. Remember, the capital M is different to the common M, where you had y2 take away y1 over x2 take away x1. That's different. This is common M, this is capital M. Next question asks. Get that right now. Oh, to find the gradient? Oh, so pick up anyway. Good, find the gradient. So guys, remember, midpoint is capital M. Gradient is common M, a small m, a little m. Good. So again, we're going again now. Kelsey, help me. Y2, take away Y1. Y2, 2 minus 6. Good. Continue. X2. Alright, what's the answer, anybody? -4 over 12. Simplify it. Huh?
Negative 3.
That negative 3. Smaller number to x on top. Negative
Negative 1 over 3.
1 over 3. Guys, don't get mixed up. The smaller number is on top. That happened to a lot of people in exams. They think it is 12 divided by 4. It's 4 divided by 12. Okay? So you with a fraction. So your midpoint is 1, 4. Your gradient is m. The next question I ask you. Guys, somebody help me what the next thing I ask you for? Find the what? You see the gradient here? So the next question is now. I don't want to move the screen. Find the what? Right, so if CD is a line somewhere, everybody want to be, CD is a line, the perpendicular bisector will be a line intersecting that line at what? 90 degrees. I said find the perpendicular bisector for CD. So then, if m's gradient is negative a third, if m's gradient is negative a third, what the gradient before the perpendicular bisector has to be? Positive 3. Good, because what? M1 times M2 has to equal to what? Negative 1. So if M2 is negative a third already, easily, you know, you have to put what? The positive 3. You see that? Now 1 is already what? Negative, and this is the reciprocal. So it's really 3. Okay, you see that? So we done got a 3 already. Y equals mx plus c. So we done m is what? 3. But we need to find the intercept. How do you find the intercept? Remember I was asking me something a while ago about simultaneous equations? We got to substitute. And what is happening here with these two lines? What is happening to these two lines? Guys, what is happening to these two lines? That means if they're intersecting, they have a common point. That's the trick with this question. When I say perpendicular bisector, that means the two lines intersecting each other. So at some point, the two lines have got a similar point. And what the similar point will be here. Right? Good. And where does a line perpendicularly intersect another line? By the midpoint. Because whenever you perpendicularly bisect any number, any line is always to the middle. Well, I didn't go there with that. Okay, so then I need some space. Right, substitute the midpoint, which we just found, right? So what's going here? What's going here? 4. 1. X is 1, sir. Plus C. 4 equals what? 3 plus C. 4 minus 3 equals C.
1 equals C.
So the equation of the line is what? When you find the equation of the line, what do you do, class? Y equals 3x. Did I say that?
Yeah.
The 3. Where did you get the 3 from? Where did the 3 appear from? What was the gradient?
The gradient, C.
The gradient of that line, the perpendicular bisector and CD must equal to what? The product must equal to, the product of the two gradients must equal to what? -1. Why -1? Because they are both what? Perpendicular to each other. You understand? So since we have negative a third here, you know that the other one has to be positive 3. Okay? And then we substitute it with the midpoints, and then you find the y-intercept. You write it back with just the gradient and the y-intercept and x and y left out. Okay? That's it for that. And there's one more question after that?
Yeah.
Take a picture of that, Colin. Everybody have that in the books? I see another scrolling going on, another typing, you know. I hope people go thinking of these things, you know. May I clean the board?
Yeah.
Pause it. Yes, sir. D, we just had it. What's the gradient for CD? I want to hear other people. Is it correct? We just had it at the board here, -1/3. Let's say another line AB is parallel to CD. So then CD is that AB, Miguel's secret. When two lines are parallel, they have the same gradient. The gradient will be equal. So this is two rules to learn. When it's perpendicular, M1 times M2 equals what? I want to hear everybody. When they are parallel, M1 equals M2. In other words, they are the same. So you don't take the thinking, don't think nothing. When you see the word parallel, they both have the same gradient. It simply means if this is let's make up one. This is 4/1, and the next line is like this. This also will be 4/1. Okay? Parallel lines have the same gradient. And you can tell why. Why you can tell why? Because they have the same one. Direction and have the same slope. The parallel and have the same slope. Okay? So when I ask again now, another line AB is parallel to CD and passes to the point O1, right on the equator of the line AB. So then you have two things already now. You have two things. You have y equals mx plus c. What do you have now? Give me the thing that you have. You say 1? Okay, good. So tell them where you get the 1 from.
Okay. Substitute.
Very good. It's parallel to CD and passes the points 0, 1. You see that? So the 1 goes here. What goes here?
Gradient.
Yeah, so I want to hear everybody. They want to hear Mr. Valman. -1/3. What's the x? 0 plus c. Thank God it's 0. What will happen? Good. So 1 equals what? C. Then you went back the equation, leaving out the x and the y. What's the equation? What's it?
Y equals -1/3x plus.
So you learn two things again today. Either something new or a little reminder. When the gradients are parallel, they are. When the gradients are parallel, they are. Then listen, when the gradients are parallel, they are. When the gradients are perpendicular, their product equals -1. And it's normally one will be the reciprocal of the other. And one will be positive and the other will be negative. Simple, common facts. Lock it off. God bless you. Not be ready, sir.